The last part that we're going to learn about the gas is about ideal and real gases. Now, we're going to describe the differences between the ideal gas equation and the van der Waals equation. Real gas is the gases which do not obey ideal gas equation, and it has the following features. The first one, in real gas, the gas molecule have a certain volume. And secondly, there are forces of attraction between the gas molecule. However, real gas obey ideal gas behavior at two conditions. The first one at low pressure and at high temperature. At low pressure, the volume of container increases. The molecules in a gas are far apart, hence the intermolecular attractive forces are negligible. The volume of the molecule is almost zero compared to the total volume, and it can be neglected. Whereas at high temperature, the gas molecules possesses high kinetic energy. This allows them free themselves from the attractive forces. So, the intermolecular forces also can be neglected. Deviation of real gas from ideal gas behavior can be shown by given graph. The graph shows the gas behave almost ideally at very low pressure and deviate from ideally when pressure increases. The graph shows the gas behave almost ideally at very high temperature and deviate from ideally when temperature decreases. The reasons of the deviation because at high pressure, the volume of the container is reduced. Therefore, the distance between gas molecules getting closer. And now, gas molecule can occupy sizable portion of the container. So, the intermolecular force, either attractions or repulsions, will become significant. Next, at low temperature. At low temperature, the kinetic energy of the gas molecules become smaller, so the attractive forces become significant. Real gas obey van der Waals equation. Since real gas does not exhibit ideal gas behavior at high pressure and low temperature, the ideal gas equation PV equal to nRT needs to be adjusted. Adjusting the equation, two parameters need to be reconsidered. The first one, attractive forces between the gas molecules, and the second one, volume of the gas molecules. For the real gas, attraction forces which act between the gas molecules will make the molecules move slower, give less impact to the wall, and pressure exerted by the real gas is less compared to the ideal gas. The term pressure needs to be corrected by adding coefficient, which is n square multiplied by A divided by V square. Therefore, the new formula of P ideal will become P real plus n square A divided by V square. Correction on volume. For the ideal gas, volume of the gases equal to the volume of container. But for the real gas, volume of container is based on the effective volume, where each molecule in real gas occupies a finite volume. The space occupied by molecules restricts the movement of the gas molecule, hence must be subtracted from the total volume. So, the effective volume of the gas is not volume of container, but becomes volume minus NB. Combining both factors into an ideal gas equation, PV equal to nRT, so when the Wolf's equations right now will become P plus n square A divided by volume square multiplied by volume minus NB equal to nRT. Value of A indicate how strongly molecules of gas attract each other. The stronger attraction of gas molecule, the higher value of A. Value of B indicate the molecular size of molecule gas. The larger the molecules or atom, the higher B value. Helium atoms have a smaller A value because they have the weaker attraction for one another compared to carbon dioxide. Helium's atoms also have a smaller B value because their atomic size are smaller than carbon dioxide. This is the example of questions that related with the real gas using van der Waals equation. In these questions, you are asked to determine and explain whether hydrogen or hydrogen sulfide molecules has a higher value of A and B, and which one between A or B is related to the boiling point. The answers are given below.